Imagine an AI that doesn't just write code, but actually engineers entire software products from a single idea. Today marks the moment Anthropic pushes their Claude 4 model into public beta with a breakthrough tool called Claude Code. This isn't your average coding assistant. It is a fully autonomous software engineer capable of independently building, testing, and deploying projects. With reported success rates exceeding 92% on rigorous benchmarks like SWE Bench Verified, we are witnessing the end of manual iteration. In this video, I will break down exactly how these agents work, why they represent a paradigm shift in development speed, and what this means for the entire software industry as we move from 2026 into a new era of autonomous creation. The launch of Claude Code on April 20th represents a definitive departure from the chat-based interfaces that have dominated our screens for years. For months, we've seen models like Sonnet 3 and Opus 4 excel at reasoning tasks, but they required human intervention to bridge the gap between a prompt and a running application. That is no longer the case. The new version introduces an agent architecture that allows the system to perceive its environment through file trees, execute terminal commands, read generated logs, and fix errors autonomously without needing human hand-holding. This capability was not an incremental upgrade. It was a complete re-architecture of how we interact with software development tools. Think about the last time you tried to build something complex using a standard IDE. You write a function, forget to run the tests, realize the database connection fails, spend 20 minutes debugging network ports, and then ask an AI for help. With Claude Code in beta, that workflow is obsolete. The system can detect that failure, hypothesize the root cause based on its deep understanding of your code base, modify the configuration files or source code directly within the environment, rerun the tests, and if successful, deploy the build to production servers. It operates with a level of continuity that previous tools simply could not match. This is the power of integrating long-term memory with agentic execution, allowing for sustained performance on complex, multi-step workflows that previously would have stalled or required constant human correction. What truly sets Claude Code apart in this beta release is its foundational reliance on the upgraded Sonnet 4 and Opus 4 models, which bring a level of contextual retention that changes everything about how an agent operates. In previous iterations, AI coding assistants often forgot the context once a session ended or struggled to maintain consistency across large code bases with hundreds of files. The new system utilizes memory-based long task performance, meaning it can remember dependencies, architectural patterns, and specific constraints from days or weeks ago while working on a current project. Consider a scenario where you are building an enterprise-scale application involving microservices, legacy database migrations, and third-party integrations. An older model might hallucinate a library that doesn't exist in your environment because it lost track of the initial requirements. Claude Code, however, maintains a persistent mental map of your project's structure. It understands why a specific component was chosen in the beginning and ensures every new file aligns with those original decisions. This coherence is critical for autonomous operation because it eliminates the forgetting problem that plagues current automated testing tools. The agent doesn't just write code. It writes code that fits into a living, breathing ecosystem it understands intimately. Furthermore, the integration of native V's code extensions and an advanced terminal interface means the AI has direct access to the developer's workflow without needing custom plugins or workarounds. It operates seamlessly within the familiar environment you already trust, reducing friction and increasing adoption rates. This level of sophistication suggests that the barrier between human oversight and machine execution is dissolving rapidly, pushing us closer to a future where developers act as directors rather than craftsmen. While the capabilities are staggering, we must acknowledge the implications of releasing such an autonomous tool into the public beta. The ability for an AI to independently build and deploy projects raises immediate questions about accountability and safety in software development. When a system makes 92% of the tests pass on its own without human intervention, who is responsible if that deployment introduces a critical vulnerability or causes a production outage? This is not merely a technical challenge, but an ethical one. The speed at which Claude Code operates could outpace our ability to verify every single line it generates. In traditional development, we have protocols, code reviews, and peer scrutiny built into the process. An autonomous agent bypasses these human checks by design. If the system decides that refactoring a core module is faster than asking you for approval, it will do so immediately. While this efficiency sounds appealing, it carries the risk of systemic errors propagating through entire supply chains or corporate infrastructures before anyone notices. Moreover, the rapid iteration speed means that security patches and compliance updates might lag behind the agent's ability to modify code. If an agent is tasked with maintaining a service across multiple regions, it could inadvertently introduce inconsistencies in how different parts of the application handle sensitive data. The industry will likely face a turbulent transition period where companies scramble to establish guardrails, human-in-the-loop protocols, and audit trails that can match the velocity of these new tools. We are entering an era where trust must be engineered with equal precision as code itself. Despite the challenges, the practical implications for developers like you cannot be overstated. For the foreseeable future, your role is shifting from line-by-line coder to system architect and quality assurance specialist. You will spend less time typing boilerplate syntax and more time defining high-level objectives that these agents can execute autonomously. The tools are ready now. The question is how you leverage them. The 92% pass rate on SWE Bench Verified is a testament to the model's precision, but it also sets a new standard for what is possible in automated testing and debugging. Imagine automating your entire CI/CD pipeline so that every change you make triggers an autonomous review cycle where the agent refactors your code, runs performance benchmarks, and optimizes database queries before you even push to the main branch. This could reduce deployment cycles from days to minutes while improving overall software quality through continuous self-correction. To stay ahead of the curve, focus on learning how to prompt for architectural intent rather than specific implementation details. Teach these agents your business logic, your security protocols, and your unique constraints. As you embrace this shift, remember that the goal is not to replace human judgment, but to amplify it with a machine capable of executing at a scale previously unimaginable. The future of software development isn't just about writing faster code. It's about building smarter systems. The launch of Claude Code marks a turning point in our history as developers. We are moving from an era of manual construction to one of autonomous engineering, where the potential for innovation is limited only by our imagination and our ability to set proper boundaries. The tools here are powerful, but they require us to evolve alongside them. If you found this deep dive into the future of AI coding interesting, hit that subscribe button and let me know in the comments what you think about autonomous software engineers taking over your workflow. Stay tuned for more insights on how technology is reshaping our daily lives.